I'm part of a team called the Specialist Modelling Group. It's a smallish team. We're just over 20 people, and we are multidisciplinary. So there is a huge range of different disciplines. There are, for example, architects like myself and Irene, but there's also engineers, structural engineers, mechanical engineers. There are acousticians, aerospace engineers, but we even have computer scientists, mathematician, even an artist. So each of them is an expert in their own field. But besides that, they're also digital experts. So most of them code, some of them wrote their own software already before they came to the team. And we see that as the kind of that one language, that computational language, that digital language that goes through the whole team. That's how they actually communicate almost. So working on a project called MBK, National Bank of Kuwait. Kuwait is one of the most complex geometrical buildings that we've done, but also we've done a lot of analysis and simulation on that. And this building is being built now, and people always think that we work purely digital. What we often do is we follow up projects all the way to construction. So even one of my guys is now on site checking things to see if it actually works and it actually all comes together. So most of the time we help the engineers and the architects. We consult internally here, but we also have our own innovation and research projects. One of the ones that's kind of interesting is our bone project, we call it internally. It really comes from the lunar project we did, the 3D printed lunar base. Because what we did there, we looked at the internal structure of the dome structure, and we wanted to optimize it where there were more forces going through, where we needed more material, so we printed more cells. So we thought, well, this is an interesting way. Can we actually come up with structures back on Earth that we optimize spatially? So we're looking now at three-dimensional spatial structures, how to optimize them, not by just thickening them, but by optimizing each of the strands, each of the structures themselves in the right direction. And this is something we're working with first with Imperial College and now with the Royal Veterinarian College. So we work with universities directly. We have one of the PhDs sitting here with us for 2 days a week. So we like working with that, like directly involved with universities and to support our own innovation as well.